3. Terms, definitions, and abbreviated terms. 3.1 Definitions. For the purpose of this international standard, the following definitions apply. 3.1.1 Alpha, a value representing a pixel's degree of opacity. The more opaque a pixel, the more it hides the background against which the image is presented. 0 alpha represents a completely transparent pixel. Maximum alpha represents a completely opaque pixel. 3.1.2 Alpha compaction, an implicit representation of transparent pixels. If every pixel with a specific color or grayscale value is fully transparent and all other pixels are fully opaque, the alpha channel may be represented implicitly. 3.1.3 Alpha separation, separating an alpha channel in which every pixel is fully opaque. All alpha values are the maximum value. The fact that all pixels are fully opaque is represented implicitly. 3.1.4 Alpha table, index table of alpha sample values, which in index color images defines the alpha sample values of the reference image. The sample table has the same number of entries as the palette. 3.1.5 Ancillary chunk, class of chunk that provides additional information. A PNG decoder, without processing an ancillary chunk, can still produce a meaningful image, though not necessarily the best possible image. 3.1.6 Bit depth. For index color images, the number of bits per palette index. For other images, the number of bits per sample in the image. This is the value that appears in the IHDR chunk. 3.1.7 Byte. 8 bits, also called an octet. The highest bit value 128 of a byte is numbered bit 7. The lowest bit value 1 is numbered bit 0. 3.1.8 Byte order, ordering of bytes for multi-byte data values within a PNG file or PNG data stream. PNG uses network byte order. 3.1.9 Channel, array of all per pixel information and particular kind within a reference image. There are 5 kinds of information: red, green, blue, grayscale, and alpha. For example, the alpha channel is the array of alpha values within the reference image. 3.1.10 Chromacity, CIE, pair of values XY that precisely specify a color except for the brightness information. 3.1.1 Chunk, section of a PNG data stream. Each chunk has a chunk type. Most chunks also include data. The format and meaning of the data within the chunk are determined by the chunk type. Each chunk is either a critical chunk or an ancillary chunk. 3.1.12 Color type, value denoting how color and alpha are specified in the PNG image. Color types are sums of the following values: 1 palette used, 2 true color used, 4 alpha used, and permitted values of color type are 0, 2, 3, 4, and 6. 3.1.13 Composite, verb, to form an image by merging a foreground image and a background image using transparency information to determine where and to what extent the background should be visible. The foreground image is said to be composited against the background. 3.1.14 Critical chunk, chunk that shall be understood and processed by the decoder in order to produce a meaningful image from a PNG data stream. 3.1.15 Data stream, sequences of bytes. This term is used rather than file to describe a byte sequence that may be only a portion of a file. It is also used to emphasize that the sequence of bytes might be generated and consumed on the fly, never appearing in a stored file at all. 3.1.16 Deflate, name of a particular compression algorithm. This algorithm is used in compression mode 0 in conforming PNG data streams. Deflate is a member of the LZ77 family of compression methods. It is defined in RFC-1951. 3.1.17 Delivered Image. Image constructed from a decoded PNG data streams. 3.1.18 Filter. Transformation applied to an array of scan lines with the aim of improving their compressibility. PNG uses only lossless, reversible filter algorithms. 3.1.19 Frame Buffer. The final digital storage area for the image shown by most types of computer display. Software causes an image to appear on screen by loading the image into the frame buffer. 3.1.20 Gamma. The exponent that describes approximations to certain nonlinear transfer functions encountered in image capture and reproduction. With this international standard, gamma is the exponent in the transfer function from display output to image sample. Image sample equals display output to the power of gamma, where both display output and image sample are scaled to the range of 0 to 1. 3.1.21 Grayscale. Image representation in which each pixel is defined by a single sample of color information, representing overall luminance on a scale from black to white, and optionally an alpha sample, in which case it is called grayscale with alpha. 3.1.22 Image Data. One-dimensional array of scan lines within an image. 3.1.23 Indexed Color. Image representation in which each pixel of the original image is represented by a single index into a palette. The selected palette entry defines the actual color of the pixel. 3.1.24 Indexing. Representing an image by a palette, an alpha table, and an array of indices pointing to entries in the palette and alpha table. 3.1.25 Interlaced PNG Image. Sequences of reduced images generated from the PNG image by pass extraction. 3.1.26 Lossless Compression. Method of data compression that permits reconstruction of the original data exactly, bit for bit. 3.1.27 Lossy Compression. Method of data compression that permits reconstruction of the original data approximately rather than exactly. 3.1.28 Luminance. Formal definition of luminance is in CIE-15-2. Informally, it is the perceived brightness or grayscale level of a color. Luminance and chromacity together fully define a perceived color. Actually, let me scroll up here. 3.1.29 LZ77. Data compression algorithm described by Ziv and Lempel in their 1977 paper, ZL. 3.1.30 Network Byte Order. Byte order in which the most significant byte comes first, then the less significant byte, in descending order of significance, MSB, LSB for 2-byte integers, MSB, B2, B1, LSB for 4-byte integers. 3.1.31 Palette. Index table of 3 8-bit sample values, red, green, and blue, with an index color image defines the red, green, and blue sample values of the reference image. In other cases, the palette may be a suggested palette that viewers may use to present the image on index color display hardware. Alpha samples may be defined for palette entries via the alpha table and may be used to construct the alpha sample values of the reference image. 3.1.32 Pass extraction, organization of a PNG image as a sequence of reduced images to change the order of transmission and enable progressive display. 3.1.33 Pixel, information stored for a single grid point in the image. A pixel consists of points to a sequence of sample from all channels. The completed image is a rectangular array of pixels. I'm going to say that again because I didn't make quite much sense of that sentence. 3.1.33 Pixel. Information stored for a single grid point of an image. A pixel consists of, and then within commas or parentheses, or points to a sequence of sample from all channels. The complete image is a rectangular array of pixels. Okay, so the parentheses really throw me off here. So let's just say it without the parentheses. Pixel, information stored for a single grid point of an image, makes sense. A pixel consists of a sequence of samples from all channels. Okay, makes sense, right? There's R, G, B, and A samples. The complete image is a rectangular array of pixels. So, right, so you have all of this data, but you're going to eventually put it into a mosaic that's just a rectangular array, right? As all bitmaps are. Okay, so that makes sense. Let's do PNG data stream 3.1.34 PNG data stream. Result of encoding a PNG image. A PNG data stream consists of a PNG signature followed by a sequence of chunks. 3.1.35 PNG decoder. Process or device which reconstructs the reference image from a PNG data stream and generates a corresponding delivered image. 3.1.36 PNG editor. Process or device which creates a modification of an existing PNG data stream, preserving unmodified ancillary information whenever possible, and obeying the chunk ordering rules even for unknown chunk types. 3.1.37 PNG encoder. Process or device which constructs a reference image from a source image and generates a PNG data stream representing the reference image. 3.1.38 PNG file. PNG data stream stored as a file. 3.1.39 PNG 4-byte signed integer. A 4-byte signed integer limit to the range of negative 2 to the power of 31 minus 1 to 2 to the power of 31 minus 1. The restriction is imposed in order to accommodate for languages that have difficulty with the value negative 2 to the power of 31. So I don't know if those are negatives or supposed to be dashes. Actually, the first... Oh, yeah, that's supposed to be a negative. So basically, they're accommodating for languages that don't differentiate between signed and unsigned values. And so we're doing 2 to the power of 31 rather than 2 to the power of 32 because we're just going to not deal with that last bit used for signedness. All right, yeah, that sounds good. So I almost think that last sentence is an errata, because I've read a lot of this. But yeah, but the basic idea is it's 2 to the power of 32 for both the lower bound and the upper... Sorry, it's 2 to the power of 31 for both the upper bound and the lower bound, because we are not going to add that other bit for signedness. Man, I'm just... Yeah, so... I don't even think there's a negative restriction. I'm pretty sure you can only have positives in this spec from what I've read before. And instead of doing 2 to the power of 32, we're doing 2 to the power of 31, because we're going to omit that signed bit at the most significant bit place. And that's going to accommodate for languages that do not differentiate between signed and unsigned integers. Okay, I've not explained this very well, and I've explained it too much, so let's keep on going. 3.1.40 PNG 4-byte unsigned integer. A 4-byte unsigned integer limited to the range of 0 to 2 to the power of 31 minus 1. The restriction is imposed in order to accommodate languages that have difficulty with unsigned 4-byte values. (3.1.41) PNG image. Result of transformations applied by a PNG encoder to a reference image in preparation for encoding as a PNG data stream, and the result of decoding a PNG data stream. 3.1.42 PNG signature. Sequences of bytes appearing at the start of every PNG data stream. It differentiates a PNG data stream from other types of data streams and allows early detection of transmission errors. 3.1.43 Reduced image. Paths of the interlaced PNG image extracted from the PNG image by pass extraction. 3.1.44 Reference image. Rectangular array of rectangular pixels, each having the same number of samples, either 3 red, green, blue, or 4 red, green, blue, alpha. Every reference image can be represented exactly by a PNG data stream, and every PNG data stream can be converted into a reference image. Each channel has a sample depth in the range 1 to 16. All samples in the same channel have the same sample depth. Different channels may have different sample depths. 3.1.45 Rgb Merging. Converting an image in which the red, green, and blue samples for each pixel have the same value and the same sample depth into an image with single grayscale channel. 3.1.46 Sample, intersection of a channel and a pixel in an image. 3.1.47 Sample depth, number of bits used to represent a sample value. In an index color PNG images, samples are stored in the palette, and thus the sample depth is always 8 by definition of the palette. In other types of PNG image, it is the same as the bit depth. 3.1.48 Sample depth scaling, mapping of a range of sample values onto the full range of sample depth allowed in PNG image. 3.1.49 Scanline, row of pixels within an image or interlaced PNG image. 3.1.50 Source image, image which is presented in a PNG encoder. 3.1.51 True color images represent 3.1.51 True color, image representation in which each pixel is defined by samples representing red, green, and blue intensities, and optionally an alpha sample, in which case it is referred to as true color with alpha. 3.1.52 White point, chromacity of a computer displays nominal white value. 3.1.53 zlib, particular format for data that has been compressed using Deflate style compression, also the name of a library containing a sample implementation of this method. The format is defined in RFC-1950. 3.2 Abbreviated terms. 3.2.1 CRC, Cyclic Redundancy Code. A CRC is a type of check value designed to detect most transmission errors. A decoder calculates the CRC for the received data and checks by comparing it to the CRC calculated by the encoder and appended to the data. A mismatch indicates that the data or the CRC were corrupt in transit. 3.2.2 CRT, Cathode Ray Tube, a common type of computer display hardware. 3.2.2 LSB, least significant byte of a multi-byte value. 3.2.3 LUT, lookup table. In frame buffer hardware, a lookup table can be used to map index color pixels into a selected set of true color values or perform gamma correction. In software, a lookup table can often be used as a fast way of implementing any mathematical function of a single integer variable. 3.2.4 MSB, most significant byte of a multi-byte value. That is end of section 3.